All right, hello students. Here's our second worksheet for the volume unit, and we're talking about here composite shapes. I'm not sure exactly what you've seen in your flipbook videos on composite shapes. Let's talk about the essential question. How do I solve volume word problems and find the volume of composite shapes? And this word composite, it really just means combined. Composite just means combined, and that means we're going to have more than one shape being represented by these diagrams. Now be aware, the only shapes you'll be learning to find volume in this unit are going to be rectangular prisms, triangular prisms, cylinders, pyramids, cones, and spheres. So everything in the composite questions will be dealing with one of those, what is that, 6? One of those 6 different shapes, and that's it. So once you know how to find those individual shape volumes, you can find the volume of any composite shape or a shape that's a combination of 2 or more of those 6 basic shapes. All right, questions 1. You should be able to write out an explanation of the difference between these 3 things. You have them in your video, and you covered them on last worksheet. The formula for the volume of a prism or a cylinder, you should know what that is. You know it starts off with capital V equals. So V equals, and then you tell me what the letters are that will designate the volume of a prism or a cylinder. And then what does capital B stand for? It's very important, class, you understand that. Capital B we're using to represent the area of a base. Small b is typically used to represent a side of a triangle, and specifically the side or a leg of the right triangle with the Pythagorean theorem a squared plus b squared equals c squared. And then letter H stands for, you should know what that stands for. These 3 right here are just practice: rectangular prism, triangular prism, and cylinder. Please make sure, class, that you are shading the base, even if you're having to draw these diagrams on your worksheet because you can't print these out. Make sure you are shading the base and circling the height, and do your best to draw an accurate shape. I know you're not going to be precise or exact unless you're very artistic or creative, but do your best to try to duplicate these shapes so you can recognize what they are as you are working through the volume calculations. All right, let's get to our new stuff. And hold on a sec, had the same issue before. This is not wide enough. Give me a moment to get a little more space here. All right, there we go. So number 6, the object above is 2 rectangular prisms attached together. What is the volume of the object? So if you look at this, we have actually 2 rectangular prisms connected together. All you have to do is find the volume of each one of these and then add those 2 volumes together to combine them to find the total volume of the shape. So class, the hardest part about this diagram is just verifying which dimension each of these numbers is representing. You can see on the bottom rectangular prism, we have a base of 10 by 6, and the height is 2. And then this smaller rectangular prism, you can see that if you look at the top of this one and call this the base, this is 5 feet. This dimension right here, I'm going to draw this out for you, that dimension is 3 feet because this side or this edge and this edge are congruent because it's a rectangular prism, and then we can use 2 to represent the height. So find the base area, the height, and the volume of the large prism, the small prism, and then you add the 2 of those together to find the volume of the total shape. And then don't forget, class, that's going to be in feet cubed. All right, next one. Question number 7. Now this one has thrown some students off a little bit because they're having a hard time recognizing what this shape represents. So what I did was I showed you what it would look like if you looked from the top down. And when you look from the top down, you can see this rectangular shape right here has been removed from this rectangular prism. And that means instead of adding these two shapes together, which you see right here, you're going to be subtracting the two shapes. So find the volume of the big rectangular prism. There's our dimensions for our base. We can use this as our height. Then find the volume of the inside rectangular prism, the one that you're getting rid of, and then you're going to be subtracting that. The big one minus the small cut out one is going to give us our volume of the entire composite shape, and that's going to be in meters, so it will be in meters cubed. One question on this one. What are the dimensions of this inside smaller rectangular prism? Well, there's a side of a base, edge of a base, there's the edge of a base, and then of course think about this, class, logically, how far is it from here to here? I'm pretty sure you're going to recognize that it's the same distance as the height of the larger prism. Alright, let's go to the next one. This works exactly the same way as the one we just did, number 7. We have a cylindrical or a cylinder shape, a big cylinder, and I want you to notice this small cylinder, look at the hole right here, this small cylinder is being cut out of the bigger cylinder. So you're going to find the big cylinder volume, or the large cylinder, then you're going to find the small cylinder, and you're going to subtract the smaller from the bigger because that smaller cylinder is being cut out of or drilled out of the larger cylinder. Now be careful here on dimensions. It's hard to read this diagram, so I gave you some help. 8 inches is the radius of the big or the whole cylinder. 3 inches is the radius of the inside or the smaller cylinder. Alright, let's continue. Alright, we got a big fish tank. It's made out of plexiglass or see-through. We can see through it like you would see at an aquarium. We've got an aquarium tank, and it's asking us to find the volume in cubic feet. Well, cubic feet is just feet cubed. In class, you know how to find the volume of a rectangular prism, so find the volume here. You're going to have a volume in feet cubed. And now here's the new thing. It's going to say, all right, if you know what the volume of that tank is, can you estimate how many gallons of water will go in this tank? In class, here's what you do. It's the same thing you did when you changed the units of measure on a ratio that had 2 different units of measure on top and bottom. Here's what we'll do. We'll take our volume. So I'm going to just put here, here's my volume right here. And then we're going to multiply it. Actually, let's change this a little bit. We know that our volume is going to be in feet cubed. So we're going to have volume times, not times, at the unit of measure is feet cubed. Class, if you want to convert to gallons, you want to put feet cubed on the top of your conversion. Oh, I apologize, not on the top. It's already on the top because this is the numerator. The denominator is just 1. We want feet cubed on the bottom so you can cancel the units of measure on top and bottom. And then we want gallons to be on top, just like when you guys were getting rid of units of measure. But in this case, what's going to happen is the feet cubed is in the numerator here, it's in the denominator here, and those are going to cancel out. And we're going to be left with gallons, which is exactly what we want to have. So take your volume measurement right here. Let's see if I drew something there accidentally, sorry. Take your volume measurement that you figured out in the first part, multiply it times your conversion, and here's our conversion. 1 gallon is equal to 0.134 feet cubed. So 0.134, and here is 1. And you know what to do. Multiply this number, numerator times numerator, denominator times denominator. The denominator here is 1, remember, so 1 times 0.34. And you're going to end up with a fraction right here. And let's move this over, because once you get, oops, that's weird. Goodness, I don't know why that's happening. Let's take this, I want to just move this gallons over. Because when you actually figure this out, you're going to actually put this in your calculator, this fraction, and you're going to get a number that's estimated to 1 decimal place. And there's going to be your gallons. So the reason we learned how to change a ratio that had 2 different units of measure into just 1 or no units of measure, this is the same strategy we used to change from feet cubed to gallons. And then this right here, I hope you guys realize, the tank should never be less than 90% filled. What's the minimum number of gallons? Well, the minimum is 90%. And you should all know that 90% as a decimal is 0.90. And so you're going to take your answer from gallons over here. You've got your total gallons, and you're going to multiply that times your percent, and that will tell you what 90% of this answer, total number of gallons, times 0.9 is going to give you 90% minimum amount of water. All right, let's continue. Can of tomato soup has a diameter of 68 millimeters and a height of 102 millimeters. Class, I'll recommend to you, when you get a word problem and then they give you the diagram, label the diagram. Label the height, 102 millimeters. Label the diameter, which is this whole thing right here. There's your diameter, and remember, I need you to convert diameter to radius, because we're going to need radius to figure out the area of that circle. This is just a cylinder. What's the total volume of the can? Well, if it's a cylinder, you know what the volume of a cylinder. It's base times height. And you know that base is equal to a circle area, pi r squared. So, figure out the base area, you know the height, find the volume. Don't forget the units of measure. And then the same strategy works here. Once you figure out what the volume is right here, we're going to put your volume right here. I want to make sure that I didn't mislead you, class. If you look at that previous question, just look at something real quick. This word here has nothing to do with your calculations. I was just labeling what your volume was. So over here, I want to make sure you know, when I write the word volume right here, this is not part of our equation. I'm just saying, you're going to take your volume, you're going to put it in this blank, and now you're going to convert this to a different unit of measure. Well, since my volume here is going to, let's see, is that millimeters? Yep. Since my volume here is going to be millimeters cubed, think about it. Do we want to cancel millimeters cubed by putting the numerator millimeters cubed or the denominator? Think about that for a moment. Hopefully you thought about this. If this is in the numerator, then I want to get rid of millimeters cubed and want to convert that to ounces. And my conversion is 37,000 millimeters cubed, or cubic millimeters, equals 1 ounce. So there's your two numbers here. Cancel out the millimeters cubed, multiply numerator times numerator, denominator times denominator, and you'll be left with ounces as your final unit of measure. And then just convert that to a number estimated, rounded to 1 decimal place. And then 93% of that ounce volume, you should know how to convert or find 93% based on the Shark Tank. Last question, number 11. Find the maximum height of a springboard diver. Remember, class, if we have a graph, you should remember this. Let me try to put this in lines so I can make it a little more accurate. Remember, for a springboard diver, if you remember doing this kind of a graph, hopefully you do, we start off at a certain height. They would typically jump, and then they would land in the water. Remember, your vertex gives you the maximum height, and it's not the x value, it's the y value. So remember, we find the x value of the vertex of a standard form quadratic as negative b divided by 2a That will give you the x value, and then you plug that into the equation for t to find the y value. And the y value will be the maximum height, or how high the diver is going to get before they start falling down toward the water. All right, hopefully that gave you enough guidance to successfully complete this worksheet. Again, as usual, if you get question numbers or parts of question numbers that you don't understand, don't be shy. Text me a question in Remind. Make sure you mention, Mr. Z, I would like help on question number 10, let's say on the Composite Shapes 1 worksheet, and I'll be happy to respond to you and help you out. All right, I hope you find math success. Have a good day.